Hello, everybody. I'm Smita Sriram. I'm the product manager for AWS Transfer Family. Today, I'm here to talk to you about running your managed file transfers to Amazon S3 and Amazon EFS over SFTP, FTPS, and FTP. So, businesses today are connected, right, globally. And what does that mean, being connected? It means they exchange data with one another, right? Between their different systems, whether the systems are in the cloud or in their on-premises data center or in edge locations. They rely on that data being exchanged at the right time in the right form. And more importantly, this data can be a valuable source for business insights that differentiates them, right? So in order to exchange that data, managed file transfer as a software provides secure and reliable way to exchange data between different systems. Like I said, either human to human or even programming to programming through a network, whether it's a public network, a private network, and the end goal is to meet some form of business critical need. There are several attributes that go into what forms a managed file transfer. One is security and flexibility, right? That's important, so that as the business grows, the software should be able to meet those needs. And then a lot of the managed file transfers support third-party integrations, whether it's integration into a storage service or even into your ERP or CRM systems. Some form of pre-processing, and in my subsequent slides, I'll go into architecture for pre-processing the data, whether it's for filtering, encryption, scanning. And finally, you might be using additional protocols like in beyond SFTP and FTP, like AS2 or HTTPS. So what are some of the signals that you get, like on when you need to use a managed file transfer, right? One is these file transfers are really important for your business. They're business critical, operations. Now, do you receive these files from your business partners, or do you share with them, or both, right? Either or both. Do you use multiple protocols, like I said, like a mix of protocols, because you want to use what your business partner is using, so that makes it easy to trade with them? Are you responsible for moving, storing, archiving, and even reporting on this data? And it's regulated data, right? It's important. It's subject to key compliances. And what we've also noticed is if you operate in one of these key verticals, right, whether it's financial services, utilities, insurance, healthcare, life sciences, media and entertainment, some form of managed file transfer is in play to connect with those business partners of yours. So now that you know that you're using an MFT, what are some of the challenges in operating one, right? For one thing, you want it on 24/7, right? Because you don't know when that critical file is going to arrive, or you need to send it out. Scaling, your businesses are growing, and as your business grows, so do needs of your storage and compute capacity, right? And that ongoing maintenance and patching, because you want to remain compliant. And then dealing with bad actors, right? You want to keep those endpoints protected from scanners, DDoS attacks, etc. And finally, and most importantly, business partner provisioning. You are talking to hundreds of these business partners, so you want to make sure you have them provisioned correctly in the system, and they are also kept up to date. And you want to also, and this is the key part of it, right? To stay competitive in your business area, you want to make sure you have the right level of visibility into the exchange data so that you can make those timely business decisions. And that's exactly the reason we launched AWS Transfer Family, right? It gives you frictionless file transfers, enabling business-to-business data exchange and analysis, right? And some of the benefits, I'll go into a little more detail in subsequent slides, is seamless migration. We've invested in a lot of features so that you can migrate from your existing integrations into AWS as is without changing the aspects that are most hard to change. It's a fully managed and globally available service, right? Security and compliance is key to us. The service integrates natively with different AWS services. It's cost effective at 30 cents an hour and 4 cents a gigabyte for upload and download, and the service is simple to use. Keying into some of the benefits that I spoke about in the previous slide, the service is highly available across 3 availability zones and scales on demand to meet your needs in real time. The service can support thousands of concurrent users of yours. As I mentioned, seamless migration is a key part of what we do, where you can import your own host keys or TLS certificates, bring your own IP addresses. Basically, the idea is the identity of your file transfer endpoints remains the same even after you migrate. The service supports a wide variety of authentication systems so that you can, again, bring your own identity management system and keep those credentials and business partner information the same. We've invested in a lot of features in security and compliance over the years. For example, you can filter incoming IP to just match that of your business partners and end users. We support VPC endpoints as well as shared VPC environment. There are a variety of data encryption options that you can use, like server-side encryption with S3, KMS, and compliance certifications like PCI, HIPAA, SOC, and FIPS. As I mentioned, the service is AWS Integrated, and what that means is the data is stored in its native format in S3 or EFS, enabling you to use a broad array of AWS services for analysis, AI, ML, processing, archiving. You can orchestrate ETLs and data processing in real time to get that data insights. And for compliance, the service is integrated into CloudTrail, CloudWatch, so you get the auditing and logging needed to meet your compliance needs. So what does it mean to migrate without impacting your existing integrations? So on the left, you have your users who are using different clients and transacting over these file transfer protocols with your endpoint in AWS. The data lands in S3 or EFS, and that opens up options to use your AWS-based data lake for machine learning, analytics, or just storing it in a database and you want to see a report in QuickSight, right? And the key benefits of this architecture are, like I said, you don't need to change your existing integrations or your existing workflows with your end users and partners, right? You don't manage any infrastructure because it's a fully managed service. And most importantly, the data is now available for you to get that analysis, for you to create those analysis and get those insights. Here are examples of some customers who are using the service. For example, you'll see we have FINRA, who have built their data lake on AWS, and SFTP is one of the important ways how they receive information from their broker-dealer firms. You have Celgene, a healthcare company, again, using to get that critical healthcare data into AWS. More recently, we have a blog post with Discover Financial Services, who have built a lot of features, including with AWS Transfer Family, to send, receive data with their business partners and ultimately use that data in AWS for their data science analysis. So this is just as an example of one of the many customers who have taken advantage of the service to move end-to-end workloads in AWS to AWS. Some of the common use cases used by these customers, data lakes, CRM, end-to-end CRM workflows, right? Get the data from your customer and build up your CRM database. Or if you want to share subscription-based data products with your end customers, right? And store it in S3 or EFS. IoT, ERP, digital content management. So these are just example use cases where, these end-to-end workflows are built on top of AWS Transfer Family. Just to show you some of the launches that we did over the course of the year, right? I don't want to go into detail into every one of them, but thematically, you see we started the year in adding 2 additional protocols last year, ended the year with EFS support, so that now if you have applications that rely on both NFS as well as require these file transfers, on the front end, you can bring those whole workloads into AWS and take advantage of a fully managed service like AWS Transfer Family, as well as a fully managed storage service like EFS. During the course of the year, we also added a lot of features for compliance, like source IP-based auth, and then FIPS compliance. We launched a service in GovCloud. All in today, as it stands, we're in 19 AWS commercial regions and GovCloud. So now I'll talk a little bit about implementing an MFT on AWS Transfer Family, right? The needs to serve an MFT workload fall under the following categories. A, security and access controls. You want to tighten up the access that you give your end users. The second one is connectors and integrations. As I mentioned, as part of a transfer family, you want to be connected to your storage options, your ERP, CRM systems, or even to external file transfer sites. The third one is data pre-processing. So before that data that arrives from your business partners makes its way into your data lake, you want to pre-process it, which means maybe scan it for malware, filter out some, any unwanted information, or decrypt the data because it comes in encrypted. So there's that pre-processing and data preparation stage that you want to do. And most importantly, and finally, is analysis and insights and getting that data into your data lake and making it part of your AWS-based data analytics tools. So first, I'll go a little bit into identity management system. So as I mentioned before, AWS Transfer Family connects into your existing identity providers, right? The way it works is, when you set it up, you would plug it in to an existing auth provider, right? In this example, I've shown Secrets Manager, but it can be any identity management system that you would supply a Lambda that's fronted by an API gateway, so that in real time, when your users log in, we would query your identity provider using your Lambda and authenticate and authorize them. So what this means is your end user credentials can stay the same, and you can keep their credentials securely stored in your current identity management system. The second part is, the first one was more around authentication. Now it's about data access controls, right? In many cases, you might want to apply fine-grained access controls, right? And you can use IAM, you can use security groups, or if you're using EFS as the backend, you can use POSIX-based fine-grained access controls, right? So that just depends on what are your needs and how you want to control visibility into this data. We have a feature called logical directories, where you can mirror existing folder structures, right? You can control how your S3 bucket or your EFS directories are made visible to your end users. You can also route them to a certain location so that they don't see the fact that you are using an S3 bucket or an EFS directory, or they don't get visibility into that level of detail. The idea being here is that you're following the principle of least privilege, giving them just the amount of access that they need to get the job done. The other aspect, like I said, are connectors and integrations, right? And this is just an example of how you would connect, right, to another party, right? In this example, what I'm talking about is you would connect to an external SFTP, FTPS, or FTP server, right? AWS Transfer Family, as it stands, gives you an inbound endpoint. What does that mean? Is you can connect, your partners can connect to your endpoint in AWS and send data to you or receive data from you. But what if sometimes your third parties already have a server and they want you to come and pull or push data to them? So this is where a framework where you would spin up a Lambda and either, in real time with all the connection information and push or pull the data and store that data in EFS or S3. You could run this connector, right, on a schedule using CloudWatch, so that when every day 7 a.m. you want to go pull this data from a vendor who's giving you value-added data, you can set it up in such a way that you can pull that data. Once you pull that data, again, the same thing, you can follow the same pre-processing and analytics that you would with your inbound endpoint. So the idea being, again, here is that you're aggregating data from external sources and bringing it into AWS for processing and analysis. Scanning and filtering files, right? Now, let me talk a little bit about why you'd want to scan and filter files, right? Now, you are receiving this data over the public internet from your third parties. And as you do that, when you bring that data, external data, into your own organization, you might have certain compliance needs that you want to check for that data, check for making sure that that data is clean and ready for use, ready for consumption by your internal systems. Right? And before you do that, you may want to run a certain set of rules to make sure it is in such a state, right? And an architectural pattern that I'm talking about here is as your end users push that data into AWS Transfer Family and it lands into your S3 bucket, you can use a put event to trigger a Lambda. Now that Lambda could do multiple things. It could be running a malware scanner, right? And what it would do is, the malware scanner would run, and if it passes it on into your clean bucket, and that's what is going to be used by the internal systems for processing. And let's say the malware scanner, turns out that it doesn't pass the scanning, you would put that into a quarantine bucket, and then you can make, you can either manually or run a program to inspect the data to see what you want to do with it. The other aspect is you can use object tagging to reveal what is the status of that object, whether it's clean or not inspected or an exception happened during the scanning. So this is just an example of architecture of how you could run a scanner to ensure that the data meets your needs, compliance needs. The other thing that this Lambda could run is filtering, right? Maybe you are expecting just a CSV from a third party, and now all of a sudden you see an image file that's landed in the bucket. What do you do with that? So that's, again, you can put it into a quarantine bucket and then inspect it, and then maybe reach out to your business partner to resend the data so that it is in the right format that you expect. Overall, this is the architecture that you might use to pre-process the data before it makes its way into systems internally for further analysis. Now, as part of that pre-processing, sometimes the data that comes to you might already be encrypted in transit. And now once you have it internally within AWS, you might want to decrypt it or use another encryption technology as you store it in AWS, right? So this architecture gives you that ability where on arrival, you can apply encryption keys. Now, the secrets manager here is useful because now you might have an encryption key per business partner. So when that file lands in S3, in that Lambda, we actually give you, as part of the object metadata, information on who sent you the data, what endpoint in AWS Transfer Family they use. And you can use that logic to uncover what's the decryption key that you've agreed upon with your business partner. Use that to decrypt the object and send it again along to the internal systems. If you can't encrypt it for some reason, you couldn't find the key, again, you'd have another bucket where the encrypted objects might still be there, and then you could, you might either want to contact your business partner to get the right key. And then I also have the architecture for the other way around. Like, what if you're making data available to them? So, your internal systems would, again, encrypt the object with the key that corresponds to the business partner and make it available in the bucket so that they can go pick up the encrypted data. Again, this can apply to a variety of encryption technologies, such as PGP, that you might need to use for data in motion. And to the most important part, right? Deriving insights, in real time into your data, right? You might want to automate data pipelines so you run ETLs for analysis, right? For example, the data lands in S3. Again, the same put event. You trigger a Lambda, which kicks off an AWS Glue job to crawl the data, put the data in Redshift, and you have QuickSight reading off of the database to give you a dashboard of data. And the great part about this automated pipeline is the dashboard is updated just as data comes in and your numbers get crunched, and you see, the analysis is more real time on what's happening in your business, right? With this architecture, you're orchestrating those ETLs and getting that rapid turnaround on business insights to help you make decisions in a timely way on using that data, right? And now, before this data comes in, you can apply a lot of the pre-processing that I talked about in the previous slide, whether you're encrypting or decrypting the data, filtering it, scanning it, maybe even applying a connector in between to fetch data from an outbound external site. So same thing, you can put together an end-to-end architecture that takes advantage of different AWS technologies to successfully run your managed file transfer workload in AWS. With that, I want to talk a little bit about a customer example who are doing something close to what I just talked about in my previous slides. As you can see, Discover Financial Services is a leading digital bank and payments company, and their business need is to help their customers spend smarter, manage debt better, save more to achieve a brighter financial future. So that is their business goal, right? And now the challenges that they were running into before using AWS Transfer Family was occasional failures and downtimes in their systems, right? Above average latencies that would lead to missed SLAs with their business partners, and complexity in maintaining all those systems, right? And that's not their business advantage, right? Maintaining and managing all these systems. When they moved to AWS Transfer Family as a solution for their file transfer, so that they could run their file transfers both inbound and outbound in AWS, they were able to experience quite a few benefits. First, it was easy for them to set up and manage. They were able to meet those SLAs, which was really important with their business users. And they reduced a lot of the operational overhead. And most importantly, that I don't have on this slide, is they were able to empower their data scientists to now use that data in AWS, whether it's AI and ML tooling, ETLs, whatnot. Now that data was unlocked and available to them to get the business insights that they needed. We have a blog post here that goes into detail on how they built this and the benefits that they experienced, if you're interested in learning more. Here are some links to some resources, an introductory video, the product video, and our reInvent 2020 presentation on setting up file transfers. With that, thank you. Thank you for your time.
Awesome. Thank you so much for that talk, Smitha. And again, just like you said, folks, if you have any questions for Smitha in Twitch chat, please get those in. I'd be happy to bring those up on stream here. But Smitha, going to some of the architecture diagrams that you showed at the tail end of the broadcast here, I think that's one of the most valuable takeaways that folks probably should have from your talk. Just how much is enabled by having Transfer Family take care of the undifferentiated heavy lifting, and then be able to use those S3 bucket put requests as the event to trigger Lambda and all sorts of other downstream operations. You talked about encryption, analysis of content. I'd imagine redaction of sensitive information that could be in those files is also something that you may be seeing. Any thoughts there? I know you mentioned it in the slide deck, but I think thinking about how to build with Transfer Family is almost just as important as the problems that Transfer Family solves for the transfer of files and data.
Exactly. No, you're spot on, right? And not all of you might want to use a lot of everything that I mentioned, but it's more of a menu that's available, right? As you bring end-to-end workloads, you're already doing a lot more in your on-prem environment, and gives you an opportunity to think through what you want to bring in and what you want to add. What more do you want to add to that architecture? So you're actually, the end goal here, Nick, is getting value out of that data, right? Which was hard to get if it's either locked up in a format or you don't have sufficient storage capacity. Now the cloud unlocks a lot of those benefits as you bring in. So now that gives you an opportunity to step back and rethink what that architecture should look like. Event-driven might be something that we take it for granted in the cloud, but that might not be the case in a system that continuously does polling, right? Now with event-driven, you simplified a lot of what you want to do with that data.
Yeah, wonderful. And I know this question isn't necessarily pointed towards Transfer Family in particular, but there's a lot of mention of terms like managed services and serverless. And I know we saw both of those in Transfer Family working with something like AWS Lambda. I guess, I'm going to give a little bit of an explanation here, but I'm curious as to your thoughts here. Some of the people in chat, I know were asking about this, so I'm going to try my best to sort of summarize the two. A managed service means that there is a set of responsibilities below the fold on operations that AWS manages on your behalf that there is no need for you to even think about. The APIs are sort of the top of the funnel that you interact with, and oftentimes that involves auto scaling and all of the sort. Now with something like Lambda, something that is serverless, while something like EC2 is still a managed service, you can enable an auto-scaling group. Lambda is entirely serverless in that you don't think about the atomic unit of what is under the hood scaling that. You don't think about whether it's on a container or an EC2 instance, and it simply scales automatically to any number of requests. So to sort of pull it all together here, Smitha, I see Transfer Family here being a managed service that manages the core infrastructure under the APIs, and whereas Lambda is the managed service and serverless in that any number of requests that you hit it with, it will automatically provision the infrastructure necessary, and then you get billed at like a per rate basis for that. Is that correct?
Exactly. Totally. And that's the part of that management overhead that you don't have to think about anymore, right? You have these services that are doing a lot of that scalability for you. Your business grows 100% year over year. You're not thinking about going and buying those racks anymore. You're not thinking about how do you tune your ASGs. All of that is built into these services that we talked about today.
Yeah, exactly. And to sort of correct myself a little bit there, I think the other thing with managed serverless, like serverless is more of an architectural design pattern, whereas managed services are a set of responsibilities that AWS inherits, like security patching and racking and stacking in the data center and so on. So something like Lambda would be both a managed service and serverless. So yeah, again, just lots of folks asking about that. So I figured I would recap. But
thank you.
Lots of folks enjoyed your talk, Smitha. So thank you so much for joining us. And thank you for being the last talk here at Pi Week Day 2.